linear inequalities. So our objective here is that we want to solve linear inequalities, including double inequalities, both algebraically and graphically. Well, what's in our toolkit? What do we know that's going to be useful for this objective? Well, we know what an inequality is. It basically means not equal. It's a mathematical statement that involves the less than sign, greater than, less than or equal to, greater than or equal to, or not equal to. But we're going to be using these inequality symbols. We're not going to be making use of the not equal to symbol. And let's remind ourselves that when given an inequality, when you multiply or divide both sides by a negative, the inequality is reversed. So here's a quick example. I'm solving for x and this inequality. I have negative 2x is greater than or equal to 6. So I need to solve for x, I need to divide both sides by negative 2. That's a 1 there. And I have x, and because in this case I divided by a negative both sides, I need to reverse the inequality, change it from greater than or equal to less than or equal to, and 6 divided by negative 2 is negative 3. Let's represent this solution on the number line. I usually just put a 0 in someplace. Negative 3 is over here to the left. Less than or equal to means a closed circle at negative 3, or some people will use a bracket here, and then less than is everything off to the left. So this is all x's that are less than or equal to negative 3. In interval notation, negative infinity up to negative 3 with a bracket on the negative 3 because it's included in the solution. And you always have a parenthesis when you're dealing with infinity. Okay, so let's take a look at a couple of examples of how to solve these inequalities. The steps are the exact same as those for solving a linear equality or an equation, with one exception, as we noted just above here 1 minute ago. If you multiply or divide both sides by a negative, you need to reverse the inequality. Okay, so steps for doing this. If the linear inequality contains a fraction or fractions, you multiply both sides by the lowest common denominator so that you're not dealing with fractions, so you're only dealing with integers. That makes your life much easier. As necessary, simplify both sides. Use addition or subtraction to separate your variables from your constant terms. In general, I like to keep my variables on my left. However, what's most important to me is I like to keep my variable term positive so I don't have to worry about this exception right here. Step 4, solve for the unknown. Again, remembering to reverse inequality as necessary. And then check algebraically using substitution, or graphically. We're going to look at graphic checks here. Okay, so solve the inequality. 3x minus 1/3 is less than or equal to negative 4 plus x. Have a fraction in this term right here. Every term is a fraction, put it over 1. So the lowest common denominator is a 3. So let's multiply both sides by 3 so that we don't have to deal with the fraction as we move things. Most of us don't like to add or subtract fractions. It's a little bit more complicated. So I'm multiplying both sides of the inequality by 3. Let's distribute. 3 times 3x is 9x. 3 times negative 1/3 is negative 1. Well, there goes that fraction. That's awesome. 3 times negative 4 is negative 12. And 3 times positive x is 3x. So there we go. Okay, both sides are already simplified, so we don't have to worry about step 2. We have a variable term and a constant term on the left, and a constant term and a variable term on the right. Okay, now we want to use addition or subtraction to separate variable terms from constant terms. Here's where I look at my variable term and I want to keep it positive, because that way I don't have to worry about this rule here. So I'm going to choose to move these 3 x's over to here, because that'll keep my x's positive. If I move my x's to the right, I would have negative x's, and then I got to remember this rule. So I'm going to choose to move my 3 x's over to the left, and which means I'm going to choose to move my constant over to the right. So I have 6 x's on the left is less than or equal to negative 12 plus 1 is negative 11. And now I'm dividing both sides by 6, which is not a negative. So I don't need to worry about switching the inequality. X is less than or equal to negative 11/6. Okay, let's take a look at that on the number line. Okay, so there's my number line. This is the inequality solution. Let's do a number line solution. I always put a 0 in there. Negative 11/6 is over on the negative side, somewhere over here. That's just fine. It's equal to, so I want a closed circle or a bracket. Less than means I'm going off into the left side toward negative infinity. So there's my number line answer. And in interval notation, as I go left to right, I come in from negative infinity, I go to negative 11/6, and I enclose that with a bracket because it can be included. Let's solve this. Let's take a look at this answer and solve it graphically. So I'm going to pull out Desmos here, if I can get my Desmos sorted. And what I want to do is I want to have this be an equation, and I want to have this be an equation, and I want to see when is this equation less than, below, as you compare it to the x-axis, this one. We want this one to be less than or below this one. So let's take a look at that. So here I am in Desmos. Hope my screen's not too bad for you with that glare. Can't help my overhead lights. So go back into here. My equation on the left, as a reminder, is y is equal to 3x minus 1/3. So there's 3x minus 1/3, and there is that line right there. In my case, it's in purple. And on the right side of that inequality, I had the equation negative 4 plus x. So y is equal to negative 4 plus x. And it came in my case, in black. I'm going to change the color. I think I can change the color. Maybe I got to hold it. I forget. I'll make it red. A little bit easier to see, I think. Okay, so the question is, when is this one less than this one? Which graphically means when is this one below this one as you look at it with respect to the x-axis. So when is purple below red? Well, there's my point of intersection, and you can see purple is below red from this point of intersection down to negative infinity as we go this way. And Desmos is giving me a decimal, negative 1.833, and that is their rounded approximation. It's the same number as negative 11/6 is negative 1.833. I don't know how, I'm sure there's a way to make that into a fraction. I'm just not so sure how to do it. I'm going to take a quick moment here and see if there's a way in any of my tools. It looks like I'm not coming up with it quickly, so I'm not going to spend any more of your time taking a look at this. But there is I would imagine there's got to be a way to have that come out as its decimal equivalency when it has when it's a rational number. So there you have it, a little graphical answer as well as a check. Okay, let's do a second problem, and let's do one that has a double inequality. Give me a moment to get my notes together. Okay, here we are. A student has taken 4 tests and has earned the grades of 90, 88, 93, and 85. If all 5 tests, and we're including the final exam, so in this case, the student has 4 tests and a final exam, and they all count the same. The final exam has the same value, if you will, the same multiplicity maybe, as the 4 tests. What grade must the student earn on the final exam so that his course average is at least 80, which means equals to 80, at least 80, and less than 90, which means it's less than 90 but not equal to 90. Okay, as always with word problems, define your variable. So x is equal to the grade on the final exam. You need to clearly define your variables so that you can solve a problem. If you can't clearly define the variable, you're going to be stuck trying to figure out what you're looking for. Okay, so we want the average. Okay, we want the average. All the tests count the same. We want the course average to be between these 2 numbers. So what is the average? Well, the average is add them all up. So there's test 1, test 2, test 3, and test 4. Now let's add the final exam in, and it counts the same. So I just need one of them. If the final exam were double, I'd put a 2 here, but it's the same. And the average, of course, add up 5 things and divide by 5. We want the average. The average is found by adding them all up and dividing by the number of scores to be at least 80. So between 80 and 90, and 80 is included. So I have my average is greater than or equal to 80, or 80 is less than or equal to the average, and less than 90. So the average is less than 90. So there is my equation. Okay, how do I solve this? Well, when you're solving inequality, you just do the same thing to all 3 parts. Well, first, let's simplify this middle piece here. We can add up all these numbers and make this a little nicer. If I add up 90, 88, 93, and 85, I get 300 and, whoops, a little quick on my 6. I get 356 plus x over 5. And I want that to be greater than or equal to 80, and I want it to be less than 90. So now we got to solve for x. Let's multiply everything by the lowest common denominator. I have a fraction here. So let's multiply everything in all 3 places by 5. So I get rid of that common denominator. Well, 80 times 5 is 400. Less than or equal to, well, this one times 5 is simply, well, I keep doing that, is simply 356 plus x. And then 90 times 5 is 450. And this inequality is a whole lot nicer to look at and work with than anything with a fraction in it. We still need to solve for x, which means I need to move this 356. So I'll subtract 356 from all 3 pieces to solve for x. Notice I did not multiply by a negative, therefore the inequalities did not need to be switched. It doesn't apply, of course, to adding or subtracting. And I have x in this case is greater than or equal to, well, 400 minus 356 is 44, and 450 minus 356 is 94. The students got some nice grades. The grades are so high that in order to be between 80 and 90, the final exam score needs to be between 44, it can even be a 44, and less than 94. Okay, let's take a look at that this is the inequality on our number line. I'll put my 0 over here this time because these are both positives. I need a 44, I need a 94. I can be equal to 44, I'm not equal to 94, and all those x's values are between those two. In interval notation, bracket 44 up to 94 with an open parenthesis shows the same answer. Now let's take a look at this graphically using Desmos. And I'll focus on this one here. I have this case, I'll have three equations. So I'll say I want a y1, let's say, to be 80. I want a y2 to be this piece here, 356 plus x over 5. And I want a third equation to be the 90 over here. And what I'm looking for is when is this one between this one and this one. Now this is a horizontal line, y equals 80, goes like that. This is a horizontal line, y equals 90, it's above y equals 80. And this is going to be a diagonal line cutting across. And we want to know when this is between that. And we know that 44 and 94 should be our answers. Let's take a look. So back into Desmos, and let me clear out, get straight down. Let's clear out these first two. Okay, so our first one is we want to set the line y equals 80. Okay, whoops, I'm going to need to, I got to see my y equals 80. Let's get my y, there it is. Let's get my sub so I can see it. Okay, my second one is that fraction, that average, y is equal to, and the numerator is 356 plus x, and the denominator is 5. And so as I mentioned, there's that kind of that diagonal line coming through, and I want it to be between 80 and 90. So let's put in the third equation as y equals 90. Whoops, I goofed there. Y equals 90. And there you have it. So I had to do a little bit of kind of manipulating in my graph to see it. But when is the blue line between the red line and the green line? Well, that takes place from here to here. And we can tap on those and we can see that takes place between 44, when x is 44, and 94, when x is 94. This blue line is between the y equals 80 and the y equals 90. So there is your graphical solution as well. So there you have it, how to work with linear inequalities.